Greetings to you, ladies and gentlemen, and welcome to Wafu TV. In our last lesson, we focused on the types of sets, and in today's lesson, we are going to be doing the relationship between sets. If this may be your first time on this channel, this is where we teach elementary mathematics and we support the education of underprivileged learners in local communities. If you want to see what we have been doing, you can visit our website at www.wafu.com. Here you are going to see where you can be of help. Without waste of time, we are going to go straight to explaining what is on the board. What are the different relationships that exist between sets? The first one is subset. What is a subset? A subset is simply two sets in which one set has all its elements coming from the other set. Now, these are some of the signs and symbols used in subset. If you find this, it means it's a subset of. If you find this, it means it's not a subset of. And if you find this, it means it's a subset of or is equal to. So you can find a subset that is equal to the mother set or to another set. With that knowledge, let us look at this example. A is 1, 2, 3 up to 10. And B is 7, 8, and 9. Be careful, this is tricky. Is B a subset of A? Be very careful in choosing your answer. So we're going to either put this or this or this in this space. So do you think B is a subset of A, or it is not, or it is equal? Now, this is the meaning of this dot. If you find this dot and a number at the end, it means this dot stands for the numbers that are not mentioned. So 4, 5, 6, 7, 8, and 9 are present in this set, but we can't see them. Therefore, B is a subset of A. So we write this sign to accept that B is a subset of A. Let's move on to another relationship. The second one is difference between two sets, and it is written as this or this. Element found in one set which are not, take note, in the other. So if you find one element in A which is not in B, it means that is the difference in that set. Let's look at this example together. Set P is 1, 2, 3, 4, 5, and 6, and set Q is 2, 4, and 5. What do you think will be the difference between set P and Q? Look at this carefully. Compare these two sets. What is missing in Q, which is in P? We have 1 here, and there is no 1 there, so we can indicate 1. 2 is here and is here, so we don't. 3 is here, but it's not here, so we can mention 3 as well. 4 is here and is here. 5 is here and is here. 6 is here and is not here, so we mention 6 as well. The difference between set P and Q is 1, 3, and 6. Let us recall something we did in our first lesson, which was called cardinal number. If you see N, it stands for cardinal number. So what is the cardinal number of difference between set P and Q? We come back to this set and count the number of elements in this set, and they are 1, 2, and 3. So the cardinal number of the difference between set P and Q is 3. With this in mind, we can move to the next relationship. The next type of relationship that exists between sets is equal sets. What are equal sets? Be very careful as far as this is concerned. If you do not understand this very well, when you get to the next, you may get confused. So let's look at this together. Equal sets. Sets with the same type. I want to highlight this. Sets with the same type of elements. So when you find a set with the same type of element in both, these are equal sets. If you look at these symbols, the first one stands for is equal to. It means if you see this, it means the set is equal to the other. If you find this, it means it is not equal to. From this definition, if you look at set V and set Z, do you think they are equal or they are not? I think they are equal because all what you find in V are in Z. 1 is here, 1 is here, 2 is here, 2 is here, 3 is here, 3 is here. Even though they are in a different order, but they are all present in both sets. So the order doesn't matter. Now I would like to emphasize this. The order does not matter when it comes to equal set, and also repetition doesn't matter. If you find one 2 times and here 1 time, it doesn't matter. So long as that type of element is in one and in the other, the sets are said to be equal. Let's get to the next type of relationship, which is equivalent set. Unlike equal set, equivalent sets are set with the same number. I want to highlight that as well. The same number of elements in both sets. Let's look at the symbols used. If you find this, it means it's equivalent to, and if you find this, it means it's not equivalent to. Others equally use this sign for equivalence. So if you find this as well, it means the set is equivalent to. Let's look